everybody, welcome to our first workshop. So we have some folks from Microsoft giving a workshop here. Who we got? We got Jen Fox, Liya and Mollie Muñoz, who are going to join us. So Jen is the senior PM for the Maker Lab at Microsoft. She makes things and teaches other folks to make things. And after settling into physics and mechanical engineering, with a blend of inventing and teaching, she joined Microsoft in 2020 as a senior program manager to learn about, experiment with, and help drive maker-related efforts across the country, the company. Liya is the principal program manager for AzureRTOS, pardon, we're a few hours in, for the AzureRTOS team. There we go. And I'm very excited to also welcome Mollie Muñoz, who is an engineer on Jen's team. All right, our guests are here. Welcome, everybody.
Heck yeah. Okay, I was waiting for a second. My computer is like, you're doing a lot of things right now. So please let me know if I'm like glitchy or whatever. My name is Jen. I think Alex gave quick intros, but I guess I should say my name. Does anyone else want to just intro yourself really quick and then I'll jump into a fun demo?
Sure, I'll go first. Hi, everyone. My name is Mollie Muñoz. I am on the Make It team with Jen at Microsoft, and I will be helping out with the workshop today, demonstrating some new tutorials we put together.
Hi everyone, my name is Liya. So I'm a program manager from the AzureRTOS team. So also with Jen and Mollie. So I'm going to talk about our product, AzureRTOS, and give a brief introduction. Hopefully we can do that within 10 or 15 minutes. We'll see.
Awesome. Cool. So for folks, hello and welcome. Super excited that you're here. We are really excited for this workshop because number one, AzureRTOS is free for most of your applications, including for hobby projects. And we also have a really rad partnership with Seeed Studio because they're wonderful and they are going to be giving away 10 XIAO SAMD21 boards to 10 random attendees of this workshop. So yay, fun. We also like free. I would agree with that. Okay, cool. Before I jump into my demo, why are we here? Well, real-time operating systems are super useful for projects or products that need to be more reliable, robust, and faster, or if you're trying to do things kind of at the millisecond level. So for example, if you're building a project for work, a project or product for other people where they're going to be poking at it and doing some funky things. I like to joke, if I can give something I make to a 5-year-old and they can't break it, it's done good. Or if you're building a personal project that needs to be super reliable, like for things dealing with home automation, using a real-time operating system, or RTOS for short, can often give you better performance than bare metal programming. That said, RTOSs can be kind of tricky to learn and implement. It's can be a little bit more involved than bare metal, especially if you're going through the Arduino route, which makes it a lot more accessible to folks like me who are lazy and just like to make things work really quickly. And so by connecting AzureRTOS with a tool that y'all are likely already familiar with, we're hoping that it will be easier for you to get started and to use it to do the things that you want to do. So basically, the goal of this workshop is to show you what's possible with AzureRTOS with a fun little water sensor demo that I'll show you in a second. And then Liya will come in and share his vast expertise to teach you more about when and why you would use AzureRTOS, and then Mollie will go over an intro application for converting the classic Blinky Arduino sample into an RTOS Blinky program. Yay, fun. Okay. So without further ado, we will start with the hardware demo. And so for that, we're going to switch to camera 2. Camera 2 is hardware camera. And I will share my screen so that you can trust that it's actually working, because classic, I wanted to add some functionality at the very last minute to get the screen to print, which I did do on this second version, but I was having some weird thread count issue. So I was like, we'll just go back to the known quantity. Okay, so here we have the Arduino serial monitor. It's scrolling pretty fast, so I'm gonna just stop the auto scroll so we can look at what's happening. So What this program is doing is it is monitoring the number of threads, or basically the different types of things that are happening in the program. It is measuring the soil moisture sensor with this red Grove capacitive moisture sensor, and that super annoying buzz that you hear. We're going to auto scroll again really quick. And this alert tells us that, oh no, our moisture is too low. We need to water our plants. And so I go, cool, the buzz is annoying. So I put it back in here. Okay, so what's rad about an RTOS, and I just learned about these, so I'm really excited to share my discoveries with y'all. We can have 3 separate threads. So this first thread is basically just a monitor thread. It's telling us what is happening. It's counting and printing to the screen the number of times that that thread is being called, or the number of times that it's running. This second thread is the moisture sensor thread. And so this is measuring the moisture of, or sorry, this is measuring the sensor value. And if that sensor value is below a specified threshold, AKA if in this case, it's kind of opposite. If it's above 600, it means it's there's not enough moisture. Then it calls thread 3, and thread 3 is what prints this alert to the screen, and it turns on the buzzer. It also turns on the onboard LED on the Wio terminal, but that's a little bit harder to see. So I was like, buzzer will be good. So if we go and look at the if we go and look at the code, this is in the Arduino IDE, yay. All right, so we're gonna see my funny, this is my attempt to print things. We'll ignore that for now. And so, oh, this is the attempt to print things. So this is the AzureRTOS ThreadX library. TX stands for ThreadX. And basically we kind of just define things as we would in the standard Arduino way. But when things start to get different is when we look at, oh, hey, look, we define our threads here. So this is thread 0. This is what our monitor is doing. This is thread 1. This is what our sensor measurement is doing. And then it calls thread 2 with a flag. And so that's why when you see the count update, it only gets updated. It's only getting called if it's above this threshold. And then our third thread is what does all the alert things. So yeah, that's a quick, very quick and hand wavy demo of why an RTOS is cool and why you might want to use it for sustainability projects like a agricultural moisture meter, which can save up to 80 to 90% of your water consumption. All right, cool. So I'm going to stop sharing my screen and hand it over to Liya.
Thanks, Jen. Let me share my screen quickly. All right. Zoom, you guys can see my screen. Awesome. Yeah, thanks, Jen, for this fantastic demo. Even though I think it's still simple, I can already use it for to save my green at home. So I always have this problems like I love to buy green, but I just don't have time to take care of them and give them like enough water, right? So end of the day, you know how situation it is, right? It looks so bad. Anyway, yeah. So just trying to give people our background of AzureRTOS, the product itself, as well as what Jen said, why we need our RTOS system for that. All right. So first of all, I'm pretty sure lots of people, audience here, are familiar with the RTOS, concept. But just to give a level set of what RTOS is and why we need it, what's the difference from the other operating system. So first of all, RTOS, as the name said, it's called the real-time operating system. So basically, it's an embedded software that is running not on those we call it PC level devices. So for PC level devices, which is running on CPU, we normally call the multi-purpose unit, the MPU, which is capable of running we call a general purpose operating system. So systems like Linux or Windows are coined as the generic purpose operating system, which are capable of running, you can imagine, tons of different applications simultaneously, and you don't need to take care of any peripheral stuff and things like that. So right, so that's the GPIO OS is for. The RTOS is running on some other devices, which we normally call the MCU device. MCU is a term as the microcontroller devices. So there are a few characteristics for this microcontroller devices. First of all, a typical microcontroller devices have much less memory than our MCU devices. So for MPU devices, we're talking about gigabyte memories. Well, for MCU, normally the memory is resource constrained, under 512 KB. And the flash is not we're not talking about the terabyte. We're actually talking about the megabyte on the device. So essentially, the computing power on that is also very different. So I think a typical MCU devices, the frequency is less than 200, while any recent modern Intel processor, easily you can get several gigabytes of the frequencies. So it's quite different. That's also because of it's used in different purposes, right? So for Linux and Windows, you're using for every scenarios, but for MCU, which is kind of normally more transparent for people day-to-day life, but actually it's more widely popular deployed in our world. So everything you can think of, your refrigerator, those kind of sensor using in the agriculture. So basically, the MCU devices is essentially using everywhere. Like a typical car, which you can have a few MPU, your control system, the central, right? The multimedia system is empowered by MPU, but essentially all the control system in the car, which can be consist of thousands of MCUs for different purposes. So basically, it's everywhere in the world. It's widely more popular even for the generic, the MPU devices we can see in the world. And then the RTOS is the system running on top of that. So it needs a few criteria for that, right? So first of all, it needs to be really small and fast because of the resource constraint, feature of that MCU devices. And it's not the Linux, Windows, you can run any kinds of application. Normally, you're running a certain purpose of application on the MCU or within the RTOS, just like Jen shows, right? You're running two threads. One is doing the calculation. The other one is actually capturing the moisture, sensor data. So normally you have a few dedicated purpose, we call it threads, right? Needs to be running with this RTOS. Of course, the most important criteria, everything has to be real-time and deterministic, means every thread has to, determine at a certain time, no matter you are running with one thread or you're running with 100 threads. So a typical example is for example, the airbag on the car, right? So which you need an RTOS system to control that, which means every time there's a emergency situation, you want this bombing of the airbag to be on the highest priority. You cannot use a Linux system let me just finish my my song and then I can just pop up this airbag, right? That will never do for an airbag. That's why you need this kind of deterministic feature for those kind of highly real-time sensitive application and scenarios. So this is just a very high-level introduction of what RTOS is and what's the difference between the RTOS and the generic purpose operating system. And why do a developer need an RTOS? So typically, for a fairly easy application, or you have a really resource constrained devices, you probably don't need RTOS, right? You can't do everything within a loop, just like you're doing typical Arduino application. So basically, you're putting everything in the loop, functionality, and basically everything is keeping looping, and you can just pull in from there and doing whatever stuff in there, right? Everything's in a big, gigantic, a while loop, infinite loop. But that just doesn't work in lots of circumstances, right? So for example, the airbag scenario, you need something we call interrupt that needs to notify, I need to give a higher priority. I need to jump into that to take over all the control. And I also need to take over all the resource of that, right? So then you come into a problem. It's you can just manage it by yourself, but that will be really resource constrained, wasting of time, or, it could be really expensive to develop by yourself, rather than you want to pick up some RTOS, which can help you to take care of the underneath stuff, which you can then focus on, doing the actual works, actual pops up this airbag. It's what this car manufacturer is caring about. right? So they were normally using some RTOSs from other like vendors for providing to them. So some other reason was like, for managing those computing cycles, it's not an easy task, right? So that's why you need some, kind of like a dedicated system that is running, underneath for that. Last reason is, especially for modern days, like, we saw more and more like those devices getting connected to the internet. So which we call the Internet of Things, right? The IoT devices. So for those kind of devices, in addition to like using the RTOS, you will normally also need some extra stuff, like, the network stack is something you want to have in the first place if you're building any like internet connected devices. So again, right, you can just develop everything by yourself, roll up your sleeve on that, or you can say, I want to use some existing, components or software for that. So that's normally also will be provided as part of the RTOS recently. If you look at like some modern RTOSs in the market, including AzureRTOS, so that's something we will provide in addition to the kernel of the RTOS itself. So that's kind of a couple of reasons that's why we see the embedded developer requires to use our RTOS system. So AzureRTOS itself, so I know quite a few people are familiar with like RTOS, like FreeRTOS or Zephyr, right? So there are a couple of like different RTOSs in the domain. So I would say, frankly speaking, AzureRTOS is like a less well-known one. That's one of the reasons we want to get it more popular and having more awareness within the community. That's why we're here, by the way. But basically, so AzureRTOS is not a new product that was developed by Microsoft from scratch. Essentially, it's a company called Express Logic, which has been in the domain for dedicatedly for developing the RTOS over the last like 25 years. So essentially, Microsoft just acquired this company because Microsoft wants to get a better job on the device end, so that can attract people to get their devices connected to the Azure cloud. That's the purpose of why Microsoft acquired this company about like 3.5 years ago. So since acquisition, so we've been keeping working on making it easier for connecting to cloud platform. So that's the last point you see on this diagram, right? So, but of course, the AzureRTOS itself, so since it's been in the domain for a long time, it's essentially with quite a few like good like features. The first of all, it's like really small and really fast. So the smallest footprint you can have to create like a typical RTOS like application, for example, with like 2 threads, which you can just interacting with each other. So that will only require to have like a 2 to 3K footprint, which is like very, very small, right? So if you want to have all the advanced features provided by the AzureRTOS or ThreadX, which is the kernel bit, so that will totally use up around like the 20 or 25 kilobyte footprint, which is still kind of small. And if you further want to add some like network stack on top of that to create some internet connectivity application, so that will come up like totally around the 50K, right? So 50K, you can have like a full-fledged like IoT, like internet connected application to running with the AzureRTOS. So of course, the performance is also good. So we can achieve this like ultra fast, like in the micro, sub-second like content switching, which is really phenomenal from the performance perspective. And one selling point is for AzureRTOS to shine out from different competitors is its like certifications. So this is especially used for if you are aiming to creating some mission critical application, for example, using in the car industry or using in the healthcare like domain or like industrial domain. So those domains are normally required to have like a set of like certifications in hand. So with AzureRTOS, so we already passed this like high level of certifications, which for creating those kind of application within that domain, you don't need to necessarily to obtain further for those certifications by yourself for those foundation code. So all you need to do is you need to further get those certifications for your business logic, but you don't need to care about those foundation code because AzureRTOS has bring that for you. Right. So last but not least, so the rich set of the middleware, so which we will soon explain a little bit later. So just briefly introduce where AzureRTOS is being used today. So as I said, so it's a product that has been in the industry for like over 25 years. So a short answer is it's actually being used everywhere, right? So like the MCU is being used everywhere. Smaller things from the wristband, like the Fitbit, like the GoPro camera, like the Honeywell thermostat, like the HP printer, which over like 90% of HP printer is actually equipped with ThreadX. I'm sorry. All the way to the bigger ones, right? Like the far right end, the March reconnaissance orbiter, which is using ThreadX to empower its imaging capturing system, right? So every image you got from Mars is kind of sort of like more or less with the help from the ThreadX as well. So the most important, interesting thing is the middle one. You see the iPhone, which doesn't mean like we are empowering the iOS, but rather than you can think of like the iPhone, which also has like the Bluetooth chip as well as the Wi-Fi. So ThreadX is used for empower its like the drivers for those kind of connectivity modules within the iPhone. Interestingly, so that's why Apple always like still pays us like some kind of money for every year for like this kind of license to be used. So overall, like, you know, this AzureRTOS, so far we had like estimate, you know, numbers that it has been deployed around like 10 billion devices worldwide over the 25 years past. All right. So last thing, so I think importantly, like, as I said, for modern IoT applications, so only have the kernel itself is probably not sufficient. So the kernel within AzureRTOS is called ThreadX, which is you actually have seen. Jen shows the demo in Arduino, which you will also see very soon. Like Mollie will walk through us with a more detailed step-by-step demo, which we're going to use the AzureRTOS ThreadX, which we have a wrapper within the Arduino so that you can use it within the Arduino environment. But in addition, we have a few set of middlewares, which helpful for different kind of purposes. So the NetX Duo is our like a TCP/IP high performance stack, which is dedicatedly used for this IoT application. PhiX is the file system. You know, if you want to use some file system for your application, so this is the stack to go. GUIX, as the name said, is like a 2D graphical, like a high performance middleware, which is using for like a graphical like application. Typically, you're going to have a screen, right? You're going to use some widgets to display some status on your devices. So this is the stack. USBX, as the name said, so normally application will connect with some like USB peripherals. So you're going to need this stack for that purpose. TraceS is our like debugging utility. So basically, all those middlewares adds up. We call it AzureRTOS, which is like a more like umbrella term of our like system components as we listed here. Yeah, so I think after the acquisition, so we've been spending a lot of time on working with our partners. So basically, you can actually free use AzureRTOS for commercial if you're using most of the chips from like the bigger semiconductors like ST, NXP, Renesas, and the quick microchip. So for that, you can just find our website. And this is our highly recommend learning materials, which is kind of totally free. It's like over 8 hours learning materials, step-by-step, very detailed, touch every perspective of the ThreadX, which you can access from the Microsoft website to learn ThreadX further. And we have like a PDF book, which is also kind of free for downloading from the GitHub. Right, so all the source code we publish on the GitHub, which you can just evaluation for free, every live source code from this GitHub, the address. And we have a couple of examples in there, which you can also use it for evaluation. Last but not least, so we will soon have an AzureRTOS channel on Hackster.io, which we will publish all of our upcoming tutorials and content on the Hackster, which is going to be a very, very useful channel for learning AzureRTOS. Make sure you check that out. All right, so I'm going to skip that and reserve the time for Mollie.
All right. Thank you so much, Liya.
Yeah.
Okay, so my name is Mollie, and I will be walking you through the very first tutorial we have written up to use AzureRTOS ThreadX on Arduino. Now, this tutorial will be published very soon on Hackster.io. It's not available yet, but we do have it available via the GitHub page for the Arduino library of AzureRTOS ThreadX. So, going to share my screen and hopefully this all works. Let's make sure. All right, can everybody see it? And is there anything else in the way? I have not done this for a very long time. We're good? Okay.
It looks great. Yay.
Yeah. All right, so this is the main page. I'm gonna try and move this little tab out of the way. As you can see, this is the site, the AzureRTOS ThreadX for Arduino. This is the library source. That the library source for when you're on Arduino and you want to install the AzureRTOS ThreadX library, this is the source code. This is where you'll come. However, I'm actually in the examples and in the demo blink serial read page. And so what I have here is there's a README along with the final code, and then the docs just contain some pictures for the README. The README tutorial is broken up into main 4 sections. You have your setup. Part 1 is where you're just going to run the Blinky example. Start with that. You can skip it if you already know how, but it's a good way to make sure your device is set up. That's why it's so short. Part 2 is where we really get into the meat of how do we convert the Blink example, which is a single-threaded bare metal Arduino application, to have the same functionality, but now incorporate the ThreadX and using the threads. That's what we cover in part 2. It ends up being the same functionality, but now with part 2 completed, you will be set up to multi-thread it and add in additional threads, in which case we will add a serial read. And then that's part 3, which is why it's now a little bit shorter, because you've already gotten through the meat of the material. So you can choose to do this in one sitting in 1 hour, or you can do it over a couple of different sections, come back to it as you like. All right, so there are some requirements. Right now, the Arduino library is dependent on using a SAMD21 or 51 chip, as well as there's 2 different ST boards that it has been verified on. So you will need to have that. We are working on expanding this list of supported hardware, but that's where we're at the moment. In the introduction, I go over some of the terms we've just covered. There are some key concepts that you'll be learning. You may already be aware of some of these, but this is what you will see. You'll see the actions on what you're going to be learning. And then there's a link to the final code. Again, oh yeah, this link goes to the list of verified boards that we use. So for the setup, this will walk you through with the Arduino IDE, how to install the AzureRTOS Arduino library. And then making sure your board package is installed for the board of your choice. For this sample, I'm using the Arduino Maker Wi-Fi 1010 board. All right, it's a SAMD board. Part 1, again, this is where you'll open up the Blink example, you'll run it, make sure everything's working. And after each section, there's a deep dive. So here's the code that you run, as well as a section that's optional to open up what is going on. So this will give you a little bit more information if you're interested. For example, here we talk about the difference between what Arduino basic setup and loop is doing and that it's a bare metal example. So if you're only interested in the code, you'll see that's available to look at. And if you want to dig deeper, you can. Now the Hackster.io tutorial doesn't have this drop-down option. That's only going to be available in the GitHub README, but the same material will be present. So in part 2, this is where we convert the Blink example via ThreadX. It's a little bit longer. And I walk you through all the pieces, and I've numbered them in the code as well. First, we're going to include the library. Then we're going to add the kernel entry function. And this was one of the concepts that we want to make sure you know about. Again, if you're not sure what that means, you can do a drop down, and it's going to give you more info on how to use this function. What does it mean to AzureRTOS? So for example, once you enter this TX kernel function, you're not going to return. So you need to make sure you're not doing any processing after it. That's really important. And then there's going to be links if you want to learn more. This is a great resource, this Microsoft Learn page. There's tons of material on ThreadX. And we're only going to be covering the very beginning of multi-threading here. So there's more that you can dig in on. We cover thread stack memory and the thread control block concepts, how to implement that. Your entry function. So this is this is the logic that's actually going to be running in the thread in this execution path. We move the logic from blink from the loop function into the thread. And notice we remove it from the loop. And then there is what's called a TX application define function. This is also unique to ThreadX. That gets defined. And then we implement where we create the thread. Now, I'm moving through this kind of quickly. This is just to give you an overview, but you can go through this at your pace. You can copy the code in. And again, let's say you copy in, okay, well, what's going on? All right, let's dig in a little bit more. Now we're going to talk, here's where we talk about the parameters, what we're using, what we're not using. There's the concepts of priority level. ThreadX has its own concept called preemption threshold. Okay, and that is unique to ThreadX. And that says, if you have a thread that has to be at least this level to or be allowed to preempt another thread. Down here, again, this is where there's going to be a little bit more information on what does preemption mean? What is a preemption threshold? Here, where are some more learning resources for me? So that'll be available to you if you're interested. If not, you can just skip over it. At this point, you'll be able to run it. Under the deep dive again, there's the full code that's been created that you can take a look at. And then a little bit more explanation. Ultimately, this is kind of the summary of what's happening. The flow you may be used to with Arduino bare metal is that you have your setup function, and then it calls the loop function internally, which will kick off that infinite loop. It'll just keep running, running, running. And that's, in a sense, it's running its own single thread. The flow for the ThreadX is going to be, you start with setup, but loop never gets called. Instead, this is where you enter that TX kernel enter function. It will call TX application define, and then it will call whatever function you have for your thread and execute it. So how are we doing on time? We're okay? I guess
yeah, go for it. You got like 5 more minutes.
We got 5 more minutes? Okay. Then I'll just breeze through the last part. At this point, you're going to have all of your meat that you need to know to implement ThreadX. And now you're going to repeat part of the process, right? You've already got the kernel entry function in place. You've already defined your application resources. And now you just want to create another thread. So similarly, you add your stack memory in a thread control block. You create another thread function that's going to be executing. You implement its logic. In this case, I'm just doing a very basic serial read that works on the Arduino IDE serial monitor. And you create your thread because everything else is already in place. And now you can run your application again. So the first application, or excuse me, the first thread just blinks that LED on and off. And now the second thread allows you to send and receive information, or I should say actually receive and transmit to the serial monitor any information you want to put in. So again, deep dive, here's the full code. This is what has been posted on the GitHub page currently. And then a little bit more information on what's going on. Again, this is our first tutorial. It's just on multi-threading. We try to keep it as simple and straightforward as we can, not get into too many details, but we're really looking forward to being able to expand on this and provide teach new concepts as we move forward, and provide you that learning path to make sure you understand how to actually implement it in addition to what the concepts are. Any questions? We can take questions. Other than that, I'll hand it back over.
Heck yeah, nice shot, Mollie. Did we lose Liya?
We might.
There are some questions. I'm answering one. I'm typing very fast. There's a question, does it work with Arduino Uno? The short answer is no. The long answer is we're trying to add more support. If you want a specific board, please go to the GitHub repo and open an issue, because that's like evidence that people want the board, and it helps us be like, cool, we'll prioritize these boards.
Yes, that's great. That'll really help us know what people are interested in.
So there are more questions. One of them was, what are the differences between FreeRTOS and AzureRTOS?
Oh, that's a very good question. There are multiple differences. I'm still learning the differences myself, but I can tell you a couple. One, FreeRTOS uses multitasking. AzureRTOS technically does not. It uses multi-threading. Sometimes those terms get interchanged. If you want to dig in a little bit more about what tasks versus threads are and the choice to use threading, there's a link in the tutorial that you can dig in on that. I would say that's the biggest thing that I'm aware of at this basic level. The other thing that ThreadX has that's unique is that preemption threshold.
And AzureRTOS has a ton of certifications, security
Yes.
certifications, like hardware certifications, those types of things. And I know that it has the most certifications. So there's that. Rad, I hope that answers your question.
I do not know. Let's say there's a question about quantity of threads. I do not know the answer to that question. Liya might. However, I do know that there's definitely going to be a limitation with respect to memory. So each thread is going to need to have its own stack of memory. And certainly if you don't have enough if you don't have enough memory for the stacks for the threads, that's going to be one of the things that limits you on how many you have.
Hey, Mollie. How is AzureRTOS different from Linux?
Oh my goodness. Well, Linux is going to be a regular large operating system. So what Liya was talking about earlier on, it's not going to be deterministic. So it's going to be very user friendly. So similar idea to Windows where, hey, a user it may be okay to let something delay just a few milliseconds to let another process complete. But a real-time operating system is deterministic. So if there's an important task that needs to happen right now, it can be prioritized and interrupt everything else going on. That's really important. For a user, I may not want, my Outlook to just suddenly open up or crash in the middle of me doing another task, just because it says it's the most important thing. That's just one difference. Great. I mean, there's a bunch, but yeah. To me, that's like a user experience kind of way to look at it.
Are there any known functions that you cannot use with threading?
When you say known functions, which libraries or a library are you referring to?
Oh, that's a great question. I'm not totally sure. As far as I know, it's like the things that you're able to do on a microcontroller, like within that are meet the laws of physics criteria, you should be able to port them into a thread. So for example, what I was working on last minute classic, I was like, I want to add some fun features 10 minutes before the demo. We'll see. Hence why I used a different board, but you can, I was printing to screen just in the exact same way that you would print to screen on the Wio terminal as with bare metal programming. So those libraries port just fine.
I can say so there's the delay function in the blink sample. Delay has its own limitations. So you'll see in the tutorial that is actually removed in favor of the TX thread sleep, which what sleep does is it actually suspends the thread. The delay function, my understanding, does not. It actually pauses everything. So delay is not something you would typically want to be using unless you had a very good reason for it. So I guess that's a function that I would recommend not using with ThreadX. I also actually discovered I was having a little bit of trouble with the millisecond function, millis. And I was digging into the clocks and how things were set. Right now, let's see here, for the supported hardware, everything I want to say is set at a 100 Hertz frequency. So when you get into the TX thread sleep, there'll be a value, a macro that says, I think it's ticks per second. That would be, what is that? Is that 100? Is that 100 Hertz? Yeah, cycles per second. And so that gets set, that's why that's supported. So depending on what your hardware is outside of this library, if it's using a different hertz setting or clock setting, you might see some different behavior there. I didn't fully figure out why the millisecond wasn't functioning as I expected.
That was great. Heck yeah. A couple of folks have asked this. Are you looking at supporting use of platform.io and VS Code as well as in the Arduino IDE?
Wait, are we looking at supporting?
I feel like you should be able to use AzureRTOS and platform.
So yes, so my understanding would be yes. So so platform.io has a VS Code extension right now. And currently there's a way to, I think pretty easily, you can look up the libraries that you want to include. Now, if the library is in the platform.io library manager and recognizes an Arduino library, it'll be easy to look up and just add in. For example, Arduino has an Azure SDK for C library that's been ported that you can look up, but when I tried it in platform.io, I didn't find it in that library manager yet. So how you get around that is there's actually a way that you can include external libraries that are not yet in the platform.io library manager. You just have to reference the GitHub page. There is some documentation on platform.io how to do that. So you should be able to get around it if they don't have it included yet. Hopefully that helps. There is a workaround.
Awesome. How does it differ from Zephyr?
I do not know. And that's a great question because I do not know enough about Zephyr. Liya?
Yeah, sorry. My Zoom for somehow just crashed and back, but anyhow. So I think Zephyr is a really great project as well. I think was kind of backed by Apache Foundation. So it does have the rich set of, the contributions, I think I would say. I think right now Zephyr is primarily supported by the Apache Foundation as well as the Nordic and Intel, I know. So they do have quite a few community contributions. So basically I would say Zephyr, FreeRTOS, AzureRTOS, very transparently, I think they're just the same RTOSes for different ways to doing things. So each RTOS has its pros and cons, but it really depends on, what kind of features that you will need. I would say StratX probably has a little bit more like advanced StratX features, like the preemptive like threshold Mollie just mentioned about. It's kind of unique for StratX, which is kind of normally very useful if you're creating like a real-time operating system, which you need like this kind of threading like preemption very often. Also things like event chaining, which is another like advanced features for StratX, which might be useful for application. But really, I would say there's not much differences. Rather, it depends on which one you are fond of, firstly, and secondly, if you're looking for certified product, so that could be like one criteria. Or if you want to have a rich set of middleware that comes with the product itself, so that also could be like a determined feature that you will go for different RTOSes. So there are a couple of them on the market, so make sure you just compare with them carefully. Yeah.
I think we're right on time. Look at that.
I am impressed. That was right at 2:15. You guys did a great job. Thank you so much for all of that. A big thank you to Jen Fox, Mollie Muñoz, and Liya for that awesome workshop. If we have any additional questions, we can filter you over to the Discord channel and answer a few more of those. Any that we missed, we'll record those and find a way to get those out to the people once the summit is over. So thank you guys again. Enjoy your afternoon. For all of you that are watching, that is the end of this session. Please trek it on over to the lobby and join our announcement with Seeed Studio. We are announcing the IoT Into the Wild contest winners. So join that session over there and we'll see you soon.
Thanks, everyone.
Thanks, everyone. Take
care.
Bye.
Bye.